Hi guys, this is the sensorless type of BLDC motor speed controller. Now guys, you can see that the packing is good. Let's open it up. The three blue wires that you see are for connecting the PCB to the BLDC motor terminals. The red and black wires are for connecting the circuit board to the battery. You can see guys that the circuit board is really compact, and behind the PCBs is the switching transistors or MOSFET. Now this is the direction changer switch for clockwise or anti-clockwise, and this is for controlling the speed of the BLDC motors. Now this is a 750 watts 48 volts BLDC motor. You might have seen me use this as a generator in a few of my previous videos, and it is from an electric rickshaw. Now BLDC motors contain permanent magnets, so they can also be used as a generator, and that generating part is utilized by this controller board as back EMF to determine the pole location. Now the blue wires are being connected to the three wires of the BLDC motor, and remember to keep as much space between the wires as possible. Now guys, we know this, it's a 12 volt 7H UPS battery that I'm going to use to run this BLDC motor. Let's measure its voltage first. Pointing towards 20 volts DC mode, and the meter is showing 12.45 volts, which shows enough voltage to run this BLDC motor. Now remember guys, this circuit is rated at 12 to 36 volts and 20 amps. So I cannot connect batteries more than 36 volts. Here positive will be connected to the red and black to the negative. Starting is smooth, as you can see. Yeah. At present it is running in the clockwise direction. Now let's reverse the direction to anti-clockwise. Simple and easy. Now guys, I'm running this 750 watts BLDC motor without heat sinks attached to the circuit, which is not recommended at all. Now guys, this is a 24 volts 5 amperes BLDC motor that I'm going to test with this circuit. Now since the motor is 24 volts and I'm connecting only 12 volts battery, so it is not going to run at its full speed, but it will run. You can see the performance is really smooth. Yeah, starting torque is also very good. Now let's change its direction of rotation. Yeah, I think it is rotating in the clockwise direction. It is a little bit difficult to determine, but if you look closely you will understand. You can see that the motor is so small and I am putting load on it, and still the speed is not reducing. The torque provided by this circuit, the controller circuit, is really good. Turning the knob right, we get high speed, and to the left, we get low speed. Yeah. And when we move the switch upwards, it is anti-clockwise, and down it is clockwise for the BLDC motor rotation. Now let's test this 750 watts BLDC motor with this 7Ah battery. Now guys, there is one very important thing. Never change the direction of rotation in the running state, like from clockwise in the running state to anti-clockwise by changing the switch. First, slow down to speed 0 and then change the direction and then start from 0 again. That's the best way. Changing the direction in the middle is bringing your PCB to maximum load and your batteries as well. Now guys, here I am doing full power testing with a very big battery pack. At present I have connected two UPS batteries together to run this 24 volts BLDC motor. The batteries have been connected in series to get 24 volts output voltage. Yeah, that's just a closer view. Yeah, changing the direction. Yeah, now it is running at full speed. The RPM should be somewhere around 2500. Now let's test this bigger motor. The batteries have been connected in the 36 volts voltage mode, which is the full load for this circuit. So guys, if you have liked this video, support my channel by simply hitting that subscribe button. So guys, this is the armature of a 12 volts 22 amps permanent magnet DC motor. Now the DC motor was damaged, so I decided to reuse its winding for making the transformer in this project. So guys, I have successfully completed the secondary high voltage winding for this boost converter, and I have given it 32 turns. Now I am doing the primary high current winding for an input voltage of 3.7 volts. Here, as you can see guys, I am removing the insulation from the newly installed transformer winding by burning it with a lighter. Now this is the center tap switching circuit that I constructed in one of my previous videos. Also guys, that transformer was not taking good enough input current in the primary winding, so I had to further thicken the winding on the primary side. Now let's connect it to the switching supply. The circuit diagram for the switching circuit will be provided in the description. Actually, it's a video link in which I constructed the video, which also contains the circuit diagram. So yeah, at the output of the transformer, I am connecting a bridge rectifier so that I can get out DC voltage, since it is a DC to DC boost converter circuit from 3.7 volts to 12 volts. So guys, I'm planning on using this 3.7 volts 8000 mAh battery pack to power up the circuit. Let's measure its voltage. Oh, the voltage is really low, it's only 3 volts and it should be 3.7. So I will have to use another battery. Yeah, this is good enough, 3.5 volts. Now let's connect it to the circuit. Here, as you can see guys, the output voltage indicated by the multimeter is fluctuating a lot. So I will have to connect a capacitor at the final output of the rectifier to improve the DC line of the overall circuit output. Now guys, the project is converting 3.7 volts to 12 volts, but the capacitor is charging to a voltage of up to 30 volts. That is because of the peak charging voltage. So it is not a problem because the overall voltage will reduce to 12 volts when I will connect a load to the capacitor. That 30 volts is an open circuit voltage, but under loading condition the voltage is 11 to 12 volts, which is the required target. Also guys, if the circuit is overloaded like under short circuit condition, then the output voltage will further reduce to up to 0 volts, which is not desired. So here you can hear the hissing sound, which indicates the switching of the transformer and that the circuit is working. Now the motor that is operating here is a 24 to 100 volts 6 amperes DC motor. It's a medium current DC motor. Now guys, I'm going to give twice more amps. Here I'm giving 16 amperes to the circuit. And also guys, the voltage initially was 3.5 volts, which was a low voltage for the battery pack. Now if the input voltage is higher, which is like a 3.7 or 3.8, then of course the output voltage will also increase up to 14 volts, which is best required. Now guys, this motor that you see here is a 32 amperes DC motor when fully loaded. So the circuit is working really nice. Now guys, you already know this one. It's a mini starter motor from a motorbike. And you can see that this circuit can also handle this much power. So guys, this circuit cannot run this DC motor for a long time because the batteries get drained really fast and the transistors get heated up really quick. So this motor might damage the circuit if used for a longer time. Now guys, this is the DC to DC converter. Now it operates at 12 volts and converts it to 220 volts for powering up high voltage loads. So you can see that this is a 9 watts LED bulb which is lighting up with this converter circuit. So guys, that's all for today's video. Thank you so much for watching it. Please hit like and don't forget to share and subscribe. Thank you.